Okay, so we're continuing to work through the rational root theorem. We're going to do some with all possible types of solutions. So we're going to start having whole numbers, fractions, using quadratic formula to have some irrationals, all that good kind of stuff in there. So these are going to be longer, a little more intensive, but I want you to see that we can use that four-step process even on the long ones. Alright, so I still need to do all of my steps the same though. So first step I need to do is identify some information. I need to identify the lead coefficient. I need to identify the constant. And the degree. So I'm looking at my first term, last term. Lead coefficient is 10, constant is 12, and is the fourth degree. So I should end with 4 zeros and 4 factors at the end of that. Great, so starting our 4 steps. So step 1. Step 1 is we're going to make our list using that rational root theorem. So we're going to list possible rational roots. We list those possible rational roots with plus or minus p over q, which represents the factors of the constant over the factors of the lead coefficient. So in this case, let's see, our constant is 12, our lead coefficient is 10. So we have plus or minus 1, 2, 3, 4, 6, and 12 all over 10. A little more complicated because I have 1, 2, all right, there's a 2, 5, and 10. All right, so again, it's a step up in complexity because we have 4 different denominators that we have to deal with when we make our actual list. All right, so we're going to start that list. So that list is, we're going to start with the denominator of 1. So plus or minus 1, 2, 3, 4, 6, and 12. Alright, I use the denominator of 1. Now I need to put all of those numerators over the denominator of 2. So I have 1 half, 2 over 2, 3 over 2, 4 over 2, 6 over 2, right? So those numerators keep that same pattern, but I have a new denominator, 12 over 2. Next denominator. It's a big list. So, over 5. So 1 over 5, 2 over 5, 3 over 5, 4 over 5, 6 over 5, and 12 over 5. All right, last one, over 10. 1 over 10, 2 over 10, 3 over 10, 4 over 10, 6 over 10, and 12 over 10. When your list is that big, you usually have doubles, so we're going to eliminate the doubles. All right, so obviously whole numbers all stay. And then we want to look at each row to see if any of them reduce down to any before. So 1/2 is 1/2, but 2/2 reduces down to 1, so we can take that out. 3/2, no. 4/2, oh, that reduces down to 2, so that can be taken away. 6 divided by 2 is 3, so that can be taken away. And 12 divided by 2 is 6. All right, so those are already represented in the row above. 1/5 needs to stay, 2/5 stays, 3/5 stays, 4/5 stays, 6/5 and 12/5. Okay, so those don't represent any duplicates. So we just want to double check the tenths. 1/10, nope. 2/10, oh, that reduces down to 1/5. So it usually reduces down to the row above it. 3/10 does not. 4/10 does reduce down to 2/5. 6/10 reduces down to 3/5, so that's represented. And 12/10, that represents 1 and 2/10, so 1 and 1/5. Oh, which is the same as 6/5. So that also. So at least it takes some of them out for us. All right, so step 2. We need to test the list, and we test it with synthetic division. So test with synthetic division, and our goal for testing with synthetic division is to find zeros. And you know this when your remainder equals 0. So when your synthetic division ends in 0, you have found a 0. Okay, so what I do first is I start with the first column, so like the 1, 1/2, 1/5, 1/10, and then I move from there. When you have a lead coefficient that is greater than or less than 1, you are most likely into the fraction area. So we will need at least one of those fractions, because we're going to have other values reduce out. So let's start with 1. All right. +1, -1. All right, so let's test 1. And let's test, I'm going to keep that longer, -1. All right, so I need to look at my coefficients from up top. I have 10, -11, -42, +7, +12. I use the plus and minus in there because otherwise it tends to get a little bit confusing. Numbers start blending together. So you don't have to, but I keep them. All right, bring down my 10. 1 times 10 is 10. -11 plus 10, -1 times 1 is still -1. That makes -43 times 1 is still -43. I don't think I'm going to be able to get all the way down to 12. All right, so that's -36. Okay, definitely not a 0. So, nope. All right, so we keep moving on. 10, -11, -42, +7, +12. See if -1 will get us there. Bring down that 10, that's -10, that's -21, that's +21, that's -21, that's +21, that's 28, that's -28, which is a bummer, because that's not a 0 either. Okay, so I'm going to check 1/2. So you do need to brush up on multiplying with fractions. You multiply with the top number, divide with the bottom number. Alright, so 10, -11, -42, +7, +12. So let's try it. 10, what's half of 10? 5. Alright, so that's negative 6, so that's negative 3, that's negative 45. Ooh, half of negative 45 is negative 22.5. And anytime you have a fraction and then you have to multiply or add with other fractions, you are nearly guaranteed, because that is going to end up being, what, 7.75. So that's a no. You can kind of see it going wrong pretty quickly there. Alright, so let's try negative 1/2. Just because the positive doesn't work means nothing about the negative. Always, always check both. Positive 7, positive 12. Alright, bring down my 10. Negative half of 10 is negative 5. That's negative 16. So that's positive 8. So that's negative 34. Alright, half of 34, so 17. I add those to get 24. See how they're all staying even, and I'm using a half, so there's a really nice and easy pattern with that. Oh look, and negative half of 24 is negative 12. Woo, we found a 0, hooray! That's exactly what we want. That's our goal. We're finding zeros, right? That's our goal, find the zeros. Okay, so this right here. Oh, not that one, just this one. All right, this is our good stuff. That's what we're going to use for step 3. Okay, so step 3, we're going to rewrite in factored form with what we found. Okay, so rewriting in factored form means using that 0 that we just found. So we're going to have two little since thens. All right, so since we know that we have an x value of negative 1/2, right? That's what we just got a 0 out of. Then we have a factor of x plus 1/2. Right, so that's what we just found. That's the 0 we just found. Right, now we need to take these, our synthetic quotient. So our synthetic quotient is 10, negative 16, negative 34, 24. So we need to talk about what that represents. So we started with this x to the 4th. So our first step of synthetic division reduces it down to x to the 3rd. So this is representing 10x to the 3rd minus 16x squared minus 34x plus 24. So we have taken a 0 out. We have reduced the x's by a factor. So we have a factored form of x plus 1/2 times 10x cubed minus 16x squared minus 34x plus 24.